All right, so we're on lesson 2.2, which is direct variation. Direct variation is a special type of line, straight line. Its equation is y equals kx, and that's over here. So y equals kx, that's the equation for it. And it's a relation where the ratio is what that's supposed to say. The ratio of corresponding values is consistent. So ignore that n right there. Okay, it's a relationship where the ratio of corresponding values is consistent. Okay, and we'll use that piece of information a little bit later. I know it doesn't really mean a lot right now, but the kind of the best way to teach direct variation is just kind of get into it because it's not that difficult to do. It's just kind of hard to explain. All right. That k value in our equation is called the constant of variation. All right? So that's our k value. It's an important piece for direct variation. And you can always find it because of it's equal to y over x. Now, what do ratios look like? So you could write it like that, right? And I could also say that's 1 to 2. What's the other way that we can write that as a ratio? As a fraction, okay? Do we have a ratio right here? Yeah, and what that means is no matter which y and x you take, if they're both in your equation, that ratio is going to be the same. Okay, so that ratio is not going to change. All right? And what that means is what we're going to do here, which is identifying whether it's direct variation or not. Okay? So we just said that the ratio has to be the same for each one. Okay? So I'm going to take y over x for each row and make sure that each one's consistent. Okay? So on the first top one, I have 2 over 1. Right? That's y over x. I want to know, is that equal to my second one, which is 6 over 3? And is that one equal to my last one, which is 8 over 4? Right? And I hear people say, yes, they are. Since they are all equal, they all reduce to 2, then yes, this is a direct variation problem. Okay? This is a direct variation problem. Let's look over here at B. All right. So B, if I go y over x, I get 4 over 1. I want to know, hey, is that equal to 8 over 2? Is that equal to 11 over 3? Yeah, this one's a no, this one's a not. The first two look good, but that third one messes up because the first two are each equal to 4. The last one is 3.75, so that's not equal to, which makes it not a direct variation. I don't care if you have 2 that are the same and then one that's not, or if you have 99 that are the same and then one that's not. As long as you have one that's not, it's not direct variation. All right. Any questions about these ones here? Okay. Another thing is, since we went y over x, what did we find here? What's that 2? What's y over x equal to? The k value. So this is my k value on both of those. If I wanted to know the equation for this one, well, it's usually y equals kx, but we know what k is. It's 2, so I can just plug in that 2, say y equals 2x. Okay, so that's the actual equation. They didn't ask us to do that on this one, but it's nice to know that we could do that if we wanted to. All right, so here we have 2 equations, and we want to know, are they direct variation or not? And on these ones, what we want to do is we want to remind ourselves, what does an equation of direct variation look like? Right? And we just were looking at one over there. So what does a direct variation equation look like? Y equals kx. So I want to say, do these simplify to make y equals kx? So here I have y, right? So I need y by itself. So I'm going to divide by 3, divide by 3. Get y is equal to 7/3 x. Is that one a direct variation problem?
Yes.
Yes. And what's my constant of variation?
7/3.
Yeah, 7/3, 7/3, 2.3 repeating, right? All of those are constant of variation. So that one looks good. Let's try b again. We need to get y by itself, so we're going to do what? Is that one direct variation? No. It's still an equation of a line, but remember, direct variation is a special type of line. Okay? So that one does not quite cut it. All right, any questions over these ones? Yes?
So it has to be a fraction?
No, what part makes this a no? We have something extra, right? There's no +1 out here. Good question. So it doesn't matter if it's a fraction, a whole number, or a decimal for the k value. What does matter is that it's only y equals something times x with nothing extra on the outside.
So y, A is a direct variation
Yes.
and
B is not. All right, so we're going to use proportions to solve some direct variations. Now, we said, what about the ratios of direct variation problems? Did the ratios change? Did they stay the same? They're constant, right? Constant means steady, don't change, right? So all the ratios are going to be the same, right? What ratio have we been using? What fraction have we? So we have, this is the equation. Yeah, that's the ratio that we've been using, right? Okay, so now, did they tell us a y and an x that belong together? Yeah, did they tell us a y and x that belong together?
Yes.
Which ones?
Y equals 9 and x.
Yeah, 9 and negative 15. Okay, so those two belong together. So I'm going to have 9, which is my y on top, and bottom I'm going to have negative 15. That ratio should be constant or the same as what other one?
What is y?
So I'm going to have another one. What's going to go on top?
Y.
What's going to go on bottom? Do we know how to solve these proportion problems? Right, you guys remember the shortcut way that Mr. B teaches us? And yeah, we go 9 times 21, which is 189 divided by negative 15, which is, I don't know, 12.6? Is that what it is? Oh, negative 12.6. It's like that. So we get negative 12.6 is equal to y, okay? Now let's stop and let's think about, does this make sense or not? All right? So 9 is less than 15, right? So it makes sense that our y should be less than 21. That makes sense. Here we have a positive and a negative. Over on this side we're going to have a negative and positive. Makes sense. Seems reasonable to me. Right? Good. Now, I've been telling you guys that it's y over x, right? Y over x. The reason for that is because that's what k is equal to. But if you guys forgot and you put x's on top and y's on bottom, x's and y's on bottom, right? Would we get a different answer or would it be the same answer? It would be the same here, right, for these proportions. It'd still be the same. It'd still be a negative 12.6. The reason why I'm having you guys say y over x every time is because that's what k is equal to, right? K cannot be x over y, right? So k is special, okay? These other ones is just kind of a nice habit to get in, that you put y on top and x on bottom, because that's what's going to matter is when it's this k value. All right. All right, so here we have a direct variation problem, and it's talking about commission. Okay, do you guys know what commission is? All right, it's like when you're working at a job and somebody gives you a little bit of money to work, but then they give you more money if you sell stuff or make them money, right? Which is a pretty good tool, right? I mean, would you work harder if the more stuff you sold, the more money you got? Probably, right? All right. So this one, a salesperson's commission varies directly with sales. For $1,000 in sale, the commission is $85. What is the commission for $2,300 in sales? Okay. Now, varies directly. Looks like that, right? We need to decide, what are we going to make x, what are we going to make y? Now, the key to this, do you got a guess?
You divide 1,000 by 85, divide 2,300 by 900.
Yeah, let's see. Let's figure it out, okay? So the way to do this, to figure out which variable belongs with which part of your problem, right? So we have, if we read this sentence right here, the one that says varies directly, right? So when we read that, it's going to be, this says y varies directly with x. So if I read this one, which one belongs with y? If it's a, yeah, they will tell you specifically that it's a varies directly problem. Unless they say, hey, here's a table. Is it a direct variation problem? Okay, that's the other way that they're going to do it. Okay. So which comes first in this sentence? The commission, right? So what's my y variable going to be? Commission. Then I have varies directly, and then last is sales, which is my x. So I have y as commission, x is sales. And that reads just like the equation reads. Right? Now, I have y as my commission. Right? Do I know any y values? 85, right? So I know y is equal to 85 when x is equal to what? 1,000. Could I use those two to find my k value?
Yes.
All right, so k is equal to what variable goes on top? Y over x. My y is 85. My x is 1,000. This is going to give me 0.085. Yep. Can I come up with an equation now?
Yes.
Yeah, so I can have y equals 0.085x. They want to know what happens when I sell 2,300, right? Is that an x or a y? An x. So I'm going to have y is equal to 0.085 times 2,300, which is something. I don't know what that is. All right. 195? $195 is my new commission. This isn't the only way to solve it. We could have solved it a few other ways. An example is, what do we know about the ratios of direct variation problems? They're the same, right? They stay consistent. They don't change. So if I take my y over x, which is 85 over 1,000, isn't that going to be equal to the other ratio using 2,300? So 2300 would go on the bottom because they're both sales, and then my Y, which is my commission, would go on top, and then we'd do the multiply and divide, and we'd get that same number. Okay? More than one way. I think that's the last one, but before... No. Okay, this is the last one. All right. So now we're going to be graphing direct variation equations. Right? So we have A and then B. We can do this a couple ways. One is by point graphing. Yes?
What made you want to decide to teach math?
That's not what we're talking about right now. All right. So we have part A, which is direct variation equation. Right? We can do this by point graphing, which just means I'm going to make a dotted lines and then connect the dots, right? So somebody give me an x value.
-2.
All right, I heard both 2 and -2. Might as well do both those. If I plug in 2 to my x value, what do I get out as a y value? I think for 2 I get 1.5, and for -2 I get -1.5. So that's 2, 1.5, -2, -1.5. All right. What other one do you guys want to try? 3. If I plug in 3, I get 9/4, which is, I guess, 2.25. And those all should be, whoa. There we go. Those should all be on the same line going up. Let's look at B. Okay. Now, does it matter which x's I choose? No, but how big is my graph paper for x's? It goes from -6 to 6, right? Would I want to choose like -20? No, I couldn't really graph it, right? So you kind of want to pick stuff that you can graph. So somebody give me an x value. 5. 7, that's graph paper. All right, so x is 5. What happens to my y? -10. What does that do to my graph paper? There's 6, 7, 8, 9, 10. Right, it's going to be about there. That's not quite as nice, so maybe 5's a little bit too big. So let's pick a number smaller than 5. 1. Plug in 1, 2 times -2 times 1 is -2. That's what I was trying to say. 1, -2. So it's like that. That one looks good. 2. Plug in 2, we get -4. 2 is -4. And we get, it's supposed to look like that. Okay, good. A couple things about direct variation problems. Where did those two meet at? The origin, right? 0, 0. Because these are a special type of lines, they will all go through the origin, which means they will all have 0, 0 as a point. But it makes sense, because what happens if I plug in 0 here? I get 0, right? 0 times anything is going to be 0. What happens if I plug in 0 here? 0, right? 0 times anything will be 0. So that's the special part of these direct variation problems. Okay. Here's your homework assignment.